Welcome to Science Time with Miss W. Now, just a few notes on the note frame. You're going to see this before you, and you're going to be like, wow, that's a lot like math. Well, it's the exact same thing. The only thing is I'm a little bit nicer to you than I am in math, and I actually write down what the purpose is. But you're still going to put the date on, because it's always good for organization, and you're going to put your name on, and I'm going to put mine as Tara. Same drill. The purpose is to talk about atomic numbers and atomic mass and what they tell us about the atom. The Q's column, that is yours to fill in with any helpful tips, any kind of, kid speak about what I'm describing here. If I write down something and it's a little bit unclear, but you can say it better and understand it better using your own words, make sure you record that in the Q's column. Okay, so let's talk about atomic numbers. Now, in the previous video that you just watched, I think that they said that our identity is given by the atomic number. The atomic number is the number of protons that they have, that a certain atom has in its nucleus. So this one right here is the atomic number. And you're noticing that this is the exact same as the colored periodic table that you were given by your teacher. This B here, that's the atomic symbol. And the biggest number on our periodic table is the atomic mass. Now these atomic number, atomic symbol, and atomic mass, they all have atomic in the title, but they have very different ways of describing the atom. The atomic symbol is pretty easy to distinguish because it's a letter instead of a number, but the atomic number and atomic mass are both numbers. Now the bigger one is going to be your atomic mass, and the smaller number is going to be your atomic number. So in general, the number of protons in the nucleus of a given atom is the atomic number. The number of electrons, since it's an atom and not an ion, which is charged, but an atom, the number of electrons and protons are the exact same. So the number of electrons also is our atomic number. With a number of neutrons, we have to kind of do a little bit of fancy footwork here. We say that the number of neutrons equals the atomic mass minus the atomic number. That's because protons and neutrons basically weigh the same thing. They weigh, in general, something called 1 mu, or 1 atomic mass unit. So if we want to know how many neutrons we have, we know the nucleus has 5 protons, but the whole atom weighs 11. So we take the atomic mass, and remember, we don't really consider the electrons because they're so light that they basically don't weigh anything. So we take the atomic mass and we subtract the atomic number, which is the number of protons, to give us the neutrons. So what about boron? What about boron? So how many protons would there be in boron? Well, if I look at the atomic number, I would say, okay, the atomic number is 5. The number of electrons in an atom of boron. Now I'm going to say atom, okay? Because if we have an ion, the number of electrons change. Okay, and you'll learn more about that next year, but this year we're going to be dealing with a lot of atoms. So the number of electrons in an atom of boron is the exact same because the charge is overall neutral in an atom. 5 protons, so plus 5. 5 electrons, so negative 5. 5 minus 5 is 0. It's neutral. The number of neutrons. Okay, so we take the atomic mass, which is 11, and we subtract the number of protons, or the atomic number, which is 5, and we get 6. So if we wanted to add units here, we would say number of protons in boron, 5p positives. Number of electrons in an atom of boron, 5e negative. And then the number of neutrons is going to be 6n0, signifying a zero charge, or a neutral charge. Let's go on to a different example here. Let's talk about sulfur. Now, just a little side note about sulfur. You're going to see it spelled a whole bunch of different ways. Maybe you're going to see it say sulfur, okay? There might be an F there might be an E. Sulfur is one of those things that is just spelled a whole bunch of different ways. So don't be thrown for a loop. It's all the same. So the number of protons in sulfur, let's just first identify the two numbers. We have this number and this number. Now the bigger number is always going to be our atomic mass. And the smaller number is going to be our atomic number. So the number of protons in sulfur is the same thing as our atomic number, which is 16. The number of electrons in an atom of sulfur is going to also be 16 because the overall charge of an atom is neutral. So they're the same amount of protons as there are electrons. The positives match the negatives. And the number of neutrons in sulfur, okay, so we take the atomic mass, which is 32, minus the atomic number, which is 16. Whew! So there are 16. So if we were to put in our units here, we would have protons as 16 protons, P positive. Number of electrons is E negative, and neutrons is N to the 0. Now I picked sulfur because sometimes the number of protons and neutrons are going to be different, just like in boron. But sometimes they're going to be the same, just like in sulfur. So 16 protons and 16 neutrons. It doesn't always work that way. Sometimes our atomic mass number is not going to be a whole number. So what about when the mass number is not a whole number? So this right here is an example of a periodic table piece on iron. And they've kind of laid things out a little bit differently. So it's nice though, because this was right at the top of the periodic table. So this was kind of like our legend. So it says right here, atomic mass number is 55.845. The atomic number is 26. So I'm just going to highlight the things that are really important to me because we don't know what electronegativity is, or the first ionization energy, or, well, we do know the chemical symbol, that's good. The oxidization states, ooh, we know the iron, the electron configuration, okay? There are lots of things that I like showing this because it kind of shows what you will be learning in chemistry in the future. By grade 12, you will know what all of these things are. But right now, I just want you to feel a little bit more familiar with it. So we highlighted the things that are important. We have the atomic number of 26. That doesn't change from periodic table to periodic table. But this atomic mass number, it's not in a whole number. So what we need to do is we must round to the nearest whole number. So the atomic mass is going to be not 55.9 or 55.8, it's going to be 56 atomic mass units, or mu. Just like that. And you literally say it like what a cat says, mu. The number of protons in iron always goes with the atomic number, so we have 26 protons, so P positive. The number of electrons in an atom of iron, so it has to be a neutral. That's a neutral entity, so an atom is neutral. So the number of protons will match the number of electrons, 26 electrons. And the number of neutrons is going to be that atomic mass, so 56, minus the atomic number, or the number of protons, because remember, all of the weight of the atom lies within its protons plus neutrons. The electrons are so light they barely weigh anything. Okay, it's called negligible. We don't count it. So we take the full mass and we subtract off the number of protons that we have, which is the same thing as our atomic number, and we're left with our neutrons. So 30 neutrons. So let's just quickly summarize here. Let's first get it into the screen. So the number of protons and electrons, not plus, the number of protons and the number of electrons will always equal the atomic number. So the atomic number for iron was 26, so we're going to have 26 protons and 26 electrons. And the number of neutrons equals the atomic mass minus the atomic number.